chemical equilibrium. Now the first thing is that the chemical equilibrium can occur in a reaction which is reversible in nature. That is the reaction which proceeds in both directions, forward as well as backwards. That is A plus B react to give you C plus D. And then once C plus D is formed, then C plus D again react to give you A plus B. Now A plus B is reacting to give you C plus D and C plus D is reacting to give you A plus B again. So if I say RF is the rate of forward reaction, and RB is the rate of backward reaction, then a time will come that rate of forward reaction will be equal to rate of backward reaction. And at this time, equilibrium is supposed to have arrived, because the amount of A and B which is reacting to give you C plus D is equal to the amount of C plus D which is reacting to give you A plus B. Now we can represent this by means of a graph. That is, if we take the rate on y-axis and time on x-axis, then initially the concentration of reactants, or initially the rate of reaction of the reactant has a certain value. Gradually the rate of reactants, the rate at which the reactants are reacting, it will go on decreasing till it comes to a constant value, and the rate at which the products react, initially they will have, their rate will be 0 because initially you do not have any products which are formed, so their rate will go on increasing till it comes to a constant value, and this indicates the equilibrium point. So you have this reactants here, the rate of reactants, and the rate at which the products react here. Now, once the equilibrium has arrived, there are certain characteristics. A, it is dynamic in nature. That is, A reacts to give you, A and B react to give you C plus D, then C plus D will again react to give you A plus B, and this process will go on. It is dynamic in nature and continues B, supposing the concentration of A or the amount of A when the equilibrium has arrived is, let's say, 5 grams, and this is, let's say, 4 grams, this is, let's say, 3 grams, and this is, let's say, 6 grams, then this amount, it will not change. Or supposing if they are liquids, the volume of this is 1 ml, the volume of this is 2 ml, the volume of this is 1.5 ml, and the volume of this is 1.5 ml again, then this volume will become constant. So the physical parameters like concentration, volume, amount, they become constant once the equilibrium has arrived. So the second characteristic of the equilibrium is that physical parameters like concentration, pressure, volume, etc. become constant when equilibrium arrives. ठीक है. Third characteristic is catalyst does not take part in the equilibrium process. That is, catalyst does not act as a reactant. It will only speed up the approach of the equilibrium. It only hastens the approach of equilibrium. For example, if the equilibrium arrives in 10 minutes in the absence of catalyst, then in the presence of catalyst, this equilibrium may arrive in 5 minutes. So the catalyst will not take part in the reaction process of equilibrium, but it will hasten the approach of equilibrium. Third point, equilibrium can be approached from any direction. Means, for example, A plus B reacts to give you C plus D. So if you start with A plus B, which gives you C plus D, and C plus D again gives you A plus C, A plus B, instead of starting with A plus B, you can even start with C plus D. That is, C plus D will react to give you A plus B, and A plus B will again give you C plus D, and C plus D will again give you A plus B, till the rate of forward reaction becomes equal to the rate of backward reaction. So equilibrium can be approached from any direction. E, can occur only in a closed vessel. The reason being, let's see from this particular reaction that I am illustrating here, N2 plus H2 gives you twice NH3, right? Now all these are gases. N2 is reacting with H2 to give you twice NH3. Now all these are gases. If the vessel is not closed, then the product which is formed, it may escape into the atmosphere. Same way, the reacting gases also may also disappear in the atmosphere. So the vessel has to be closed. Or you can take another example. Water liquid, this is a physical equilibrium, of course, converts into water gaseous. Now, if liquid water is converting into gaseous state, if the vessel is not closed, then these water vapors may escape into the atmosphere. So the vessel has to be closed. And the last point is, equilibrium only occurs in a reversible process. For example, A plus B is reacting to give you C plus D. For the occurrence of reaction, there has to be a forward reaction and there has to be a backward reaction. And when the rate of these reaction becomes equal, equilibrium arrives. So the process has to be reversible in nature. I hope you like the video. Please subscribe, like and share. Thank you so much.